In this lesson, we discuss about public key certificates, also known as digital certificate. So far, we have not involved any kind of central authority who can exert some kind of authority. And the way to address the authenticity problem of public key, which we have discussed in earlier lesson, is to bring in such an central authority. You may have heard about Bitcoin and blockchain and all that, which claims to bring in this decentralization property, which can dislodge the requirement of central authority and all that. But unfortunately, in the case of addressing the authenticity problem of public key, central authority, also known as certification authority, is required. So let's look at our previous example again. We have a public key directory where the public keys of the user or the employees of the organization are being stored. If the attacker wants to replace a public key, it is possible because this directory is accessible by public, unless we bring in this central authority who produce certificates of the public key. And that is the concept behind. So how does it work? The process is just like when you're trying to get an identity card or a passport from an ICA, Immigration Checkpoint Authority. You have to provide all the necessary information to the ICA, in the case of the certificate, to the certification authority. And then they will verify everything, your identity information, your address, your phone number, whatsoever that is required to be certified. In the case of the digital certificate, the public key of your public key and your identity information and other information that has to be certified against, you have to provide, and they will check all this information. And only when everything checks out, and this checking out process could be a manual process, okay? And only when everything checks out, they will produce you a certificate like this. So it's just like when you have to produce a passport when you go to another country in the immigration checkpoint. It is very hard for the attacker to produce a passport of another person because passport is issued by a central authority. And typically passports are very difficult to forge. So it is the same process here. The certification authority will sign the public key of the user and the identity information of the user and some other necessary information with the private key of the central certification authority. So unless the attacker can somehow steal the private key of this certification authority, this certificate cannot be forged. So in this case, when certificates are being produced, what happens is in the directory, instead of the public key only, now what we have are the certificates. Of course, certificate include the public key itself. The public key is part of the information included in the certificate, but it will additionally include the identity information of the owner of the public key and also the identity of the CA itself, and also the signature signed by the CA using its own private key. So when we do this, unless this attacker has somehow the private key of the CA, it is impossible for him to forge a certificate, to forge his own certificate, so as to impersonate Alice or Bob or Charlie or whatsoever. So in that case, instead of public key directory, let's call it as public key certificate directory. And that is in fact the typical scenario, okay? So the directory that we have nowadays, our public key certificate directories, which stores the certificates of the users or the employees of the organizations. So just like immigration control authority in the real world, the certification authority also exists in the real world. In short, let's call them as CA. So who are the CA? CA can be any trusted third party. Notice the keyword trusted. Of course, a CA has to be trusted, otherwise they themselves may be forging the certificates. So CA will be the trusted third party that are authorized to issue public key certificates to user. There are many CAs throughout the world. In Singapore, we have NetTrust. You can check out the link that is given here. And also there is a worldwide organization called VeriSign. But having said that, in the world of the internet, of course, it is likely that, let's not say likely, there are many untrusted certification authorities. Later on, we will discuss about the issues with untrusted authority. Okay, but in the general sense, when we discuss, when I say CA, I mean it's a trusted third party, trusted central certification authority who issues the public key certificates to the users. We will discuss the topic about untrusted CAs in the next lecture. So typically, CA will be issuing certificates to the users. Of course, CA himself will have a pair of public key and private key, and CA will be using the private key to sign the public key of the user, let's say Alice, and also the identity information. And then it will produce a CA, and all this information together, it is called certificate. And it can be done for any other users who wants to obtain a certificate. Of course, since this is a manual process, it will come with a certain fee. So getting a certificate is not free. So this slide shows you the mandatory components contained in this so-called X.009 certificate standards. There are a few other standards as well, but we will only be concerned with this X.509 standard. It contains the version number. The version number is the version of the certificate standard that is in use, serial number of the certificate, subject identifier. Subject identifier is the identity information of the owner of the public key who wants to certify against. Issuer's identifier. Issuers means it's a CA. So CA ID information will be contained here, will be included here. And the public key of the owner, so the public key itself will be included as part of the certificates. And also the validity period, the starting date and the expiry date, and the signature itself. The CA has to sign over this information, and we have learned about digital signing. When someone signs over information, what is the property that is being achieved? The properties that is being achieved is called integrity property and authenticity. So what it means is that when the CA signs this information using its own private key, unless somebody has that private key, this information cannot be tampered with anymore. So that means this information, you can rest assured that it is authentic and it has not been modified. But the only possible issue that you might have right now is, what about the verification process? What if someone wants to verify the authenticity and integrity of this information? Of course, you would have to use the public key of this CA, right? And then the question comes, how does one obtain the public key of the CA? And we will address this problem in the upcoming lectures. For now, just assume that the public key of the CA can be obtained in a secure way. So we have to establish this first, at least for now. Okay, and once we establish that, then you can rest assured that taking the public key of the CA, anyone can verify the authenticity of this message, the information here, and its integrity, meaning that this message has not been modified. The last information is about the thumbprint, and then I will give you a homework right here for you to check out the difference between the CA signature and the thumbprint. This slide is just to show you a real certificate example. So as you can see here, it contains a version number, a serial number, and information like the identity information of the issuer. So this is the ID of CA, this the certification authority, and validity periods. And this is the owner information, the owner of the public key, John Smith, and this is his email address. And this part here, right here, is the actual public key. Okay, so this thing is the actual public key. If you remember, modulus n, and exponent, and some other information. And the last one is the signature of the CA. Okay, so the CA will sign over all this information, and then the result is a signature, and signatures will look something like this.